Okay, so good morning, everybody. Like Tapan was saying, now we look at the challenges that we have in the water sector in agriculture with the increasing climate variability generated by climate change. First of all, let's have a little look at what is the status of water resources in California on an average year like 2010. Here you can see that when we put together both the precipitation and the import from the transboundary river, we have about 200 million acre feet per year. Of these, 39 are for environmental use, and agriculture has 33 million acre feet. So, but in total, we have that the annual, let's say, total beneficial water use is around 8.5 million acre feet per year. Although, as we said, this is not a fixed amount, it changes from year to year, but on an average year, that's what we generally have. And the distribution of this water, the share of these water resources among the various sectors is shown in this slide, where you can see that the environment takes 49% of the total beneficial water use. And this is used for rivers, in-stream flow, but also the one required to push back in the delta the intrusion of water from the ocean. In addition to some managed wetlands. Then agriculture, mostly irrigated, essentially, takes 41%, while the remaining 10% is for the urban and industry. Generally, these water resources that come from rainfall, but mostly from snow from the Sierra. And the way generally is harvested all the runoff on 40% of the area in the north that collect 90% of the water resources that then goes toward the south, where the majority of the demand is Central and South California, while most is harvested in the north. And of course, the distribution of this water occurs through different, projects of canal and conduit. In addition to the fact there are a lot of reservoirs also along the Sierra to collect the snow melt from the Sierra Nevada. So aqueducts and but we have also transboundary water, like we said, like in the case of the Colorado River, but also from the north coming from Oregon. A couple of areas in below the delta, and in central California, circled in red in this case, are isolated in terms of hydrological connection, and they are mostly based on groundwater where it's available. Now we start to see that the problem, one of the major challenges that we are having is about the variability. And drought is one of those events that comes periodically with some recurrence and so on. And for instance, using this drought severity index, we see that, for instance, we had several droughts between the 2014, 2015, 2016, and then we started to mild down in 2018 and particularly in 2019. But then again, the drought came in 2021, and this was the situation, for instance, last September 2022. Then the rainfalls and the snow melt arrived. Basically, we are already in February this year. We have that situation of drought is basically gone. And when we look, in fact, in March, we are in good condition now. Though this variability and somehow unpredictability of those occurrences makes the planning of water resources, the allocation, always very, very challenges. Another way to look at this variability is to look at the snow melt from the Sierra. We have said before that most of the precipitation are coming under the form of snow. And here, for instance, we have the cumulative precipitation from October to October of the year along the reservoir of the northern Sierra. The shaded area, this shaded area represents the average of almost 30 years. And you can see that several years are below, others are above. This is the current case for this year. But this enormous variability is what makes it very challenging to make the planning of the water resources. This is in the central Sierra, and here the difference, you see the same variability going above and below the long-term average, but you can see also how we go from the north to the south. This precipitation cumulatively are reduced. We have heard a lot about the temperature increase and particularly minimum temperature for the chilling factor, but also you have heard about the pollination implication. But for us is also an implication on the supply distribution, but also on the crop water demand, the peak that keep changing in some and concentrating in some months. So the warmer temperature during the winter provide, let's say that the precipitation goes mostly as a rainfall and less as a snow. We talked about the chill requirement that is reduced. We have seen that the runoff, for instance, between April and June has been declined by 10% in the last century. And then also there is an important occurrence, the shift of the peak of the snow melt. Basically here, you can see the snow melt waves of the Sierra Nevada in the first half of the century, 1906, 1955, in red. And then in the second half of the century, 1956, 2007, in blue, you can see that the peak has been shifted earlier in time. So this shift prevent the fact that we have already the reservoir that are already in part full, and they cannot be filled more than their capacity, also for security reason and so on. So we lose some water of this snow melt if the peak of the snow melt comes too much early in time. And in any case, we have a projection that this is the historical range until 1990, and when this one, while these are the projection. And if we look at the projection on the lower warming range until 2099, we can see that we might lose 48% of this snowpack. And then if we go, instead of the worst scenario with a high warming range, we may lose 65%. Which is a quite important losses in prospect. The other point also to consider is the fact that we have the continuous depletion of groundwater. Here is just the cumulative groundwater depletion in Central Valley, and this starts already from the 60s. And we can see here, for instance, that there are also dry year, wet year, and during the dry year, the slope of the withdrawal is much steeper than during the wet year when there should be some recharge of this groundwater. And this continuous trend in terms of depletion of groundwater is worrisome For instance, some concern are for Tulare Lake, South Coast, and Colorado River areas, basically where the groundwater level has declined of more than 7 meters between 2011 and 2017. And this is also the reason why there is the establishment of the Sustainable Groundwater Management Act. And this overimpose to the restriction, let's say, in water availability from climate. Here, for instance, I wanted just to report the Public Policy Institute in California releasing last month this policy brief on the future of agriculture in San Joaquin Valley. And there they clearly state that by 2040, average annual water supply could decline by 20%, constrained chiefly by transition to groundwater sustainability under the sigma, but exacerbated also by the climate change and environmental regulation. So when we look at long-term of water-related implication, we can see that we continue to have population grow in California. We already reached the 40 million. And the implication of this that you need additional domestic production of food to satisfy the demand of this growing population. Also, we have observed over the years that more agricultural land, particularly also irrigated land, have been encroached by the urban settlement. And so this reduction in agriculture and irrigated good land implies that the production will progressively move in marginal land, in less fertile lands, with implication also for that you needed to compensate the lower, let's say, fertility with additional inputs. In terms of long-term trend of irrigated agriculture, we observe that there is an increasing concentration of the irrigated land. The most relevant area are San Joaquin Valley, Sacramento and San Joaquin Delta, and the Imperial Valley. Consider that 35% of the US table food is obtained basically on only about 1.2% of the US farmland. So this is to see how much the concentration of irrigated agriculture is also occurring. Also, the cropping pattern is intensified. Conversion from annual to perennial, like fruit nuts, crops like fruit nuts and vines, higher planting density and inputs, and shift from surface irrigation to macro drip and micro sprinkler irrigation. This is also the result of a push by the legislator from water agencies and regulators that intend to, by increasing the efficiency of the irrigation system, to have some water saving, water conservation, which most of the time it doesn't mean that you can save maybe a farm level, but that water never leave the farm. Actually, the farmers may extend or their land, their irrigated land, or increasing the intensity of their cropping system. So the trend now of the crop is that both, in terms of irrigation, the gravity of surface irrigation is going down, while is increasing the drip and subsurface. And also, like we see on the other graph, the crops, like field crops, are decreasing, while the orchards and vineyards are increasing. So higher productive crops. But this means also requiring better skills in irrigation scheduling and management. We talked about the economic productivity of water by changing this toward this crop, like orchards type. The water productivity has been increasing from, for instance, $680 per acre feet of the 2000 year to $910 per acre feet of 2010. So there is let's say, a push toward higher productivity, and one of the aspects that has allowed this increase in water productivity is, in fact, moving toward a higher precision, let's say, irrigation system, like the one of drip and micro irrigation in general, and moving a little from the surface one. So what to expect in the future is that the water supply will be limited and more regulated for all users. The water rights and water tariffs most likely will need to be revisited. Larger quota of water are being transferred from agriculture to urban areas and the environment. Never forget that the environment already share a large quota. And climate change and increasing weather variability will worsen problem of water supply. And we don't have only drought and floods, but also we'll have other extreme events like frost and heat waves. So we need a cropping system that use less water, adapt to lower quality water also, benefit from rainfall and flow capture during the fall and winter months. As we have seen, we needed to capture those water as much as possible in order to benefit from and not to lose that water runoff. And in terms of irrigation system, we need irrigation that are of high precision. So the trend will continue, high precision, because these allow to apply water with small amounts, frequent intervals, so to deploy high application efficiency and uniformity. In a way, gives the opportunity to manage better the stress of the plant. And we know that for nuts crop particularly, there are stages of the orchard during the season where they are less sensitive to water stress. So this will allow also us to use deficit irrigation. Deficit irrigation, which is the application of water below the full requirement of evapotranspiration, provided, of course, you take care of the salinity buildup. So the deficit irrigation, which has been proven to be effective, at least in several other countries, is well versed to be used with the nuts crops. So this is something that can respond also to the management of irrigation under variability, assuming that you have the right allocation of water. Also, to use the prospect management strategies, making use of forecasting tools. So we try to use also opportunity to forecast at least a couple of weeks in advance for the irrigation, for the scheduling of irrigation, in order to better adjust and having this management strategy that can allow to cope with the variability of climate. Here, there are some useful links that we would like to provide when the presentation will be distributed or will be accessible. And here you can find not only information on water resources, but also some dedicated webinars on droughts and some tip sheets that will help to manage better the drought. And with that, I think I will stop here, and thank you for your attention.
What research is being done on deficit irrigation?
What? Yeah, there are several done. Also in California has been done in the past, but there are new research, also most recent research done in Spain, done in southern Italy, done also in Australia. So there are several of these research studies that can be useful to adopt for, now how much experimentation is done by the cooperative extension on deficit irrigation, I don't know. Daniele, you know more?
It's been done. There's some research done by David Goldhammer on pistachio and almonds during the late 90s. But the cropping system and planting density varieties were different with respect to what we have now. So probably it's about time to do it again. Yeah.